Hi everyone, I'm Mahalakshmi, Assistant Professor, St.Josephs College of Arts and Science, Kogu. Now, in this video, you have to see a digraphs and matrix. Already we explained about what is digraph, the adjacency matrix for simple graph. In this video, adjacency matrix for digraph. The digraph concept is nothing but directed graph. Directed graph means the edge having some directions. Here V1 to V2. Suppose simple graph that have only simple edges. The direction is not considered. In digraph, the direction is important. Okay. Using this directed graph or digraph, we can make a adjacency matrix. Adjacency matrix, the order of the adjacency matrix is nothing but the order of the vertices. Here, how many vertices is there? 5 vertices. Therefore, the order of this adjacency matrix is 5 cross 5. First, we write the matrix V1, V2, V3, V4 and V1, V2, V3, V4. This is 5 cross 5 matrix because here number of vertices is 5. Therefore, the order of the matrix is 5 cross 5. Okay. How we can write this matrix? First, V1 to V1. Here there is no any self looping from V1 to V2. Therefore, this is 0. Next, V1 to V2. V1 to V2. Here one arc is exist. V1 to V2. This arc direction from V1 to V2. Therefore, we can write 1 here. We can write 1. But in this case, in this diagram, we can note V1 to V2 is, we consider one arc, but V2 to V1 here 0 because the direction is V1 to V2. Therefore, we can consider from V1 to V2. Next one, V1 to V3. See the picture, graph V1 to V3. V1 and V3 are non-adjacent. Therefore, simply we can write 0. Next, V1 to V4. V1 to V4. The both vertices are non-adjacent. Therefore, here also 0. The value is 0. V1 to V5. V1 and V5 are non-adjacent vertices. Therefore, here we can write 0. Next, V2 to V1. See, V2 and V1 are adjacent vertices, but in here we are discuss about digraph. Therefore, V1 to V2 is the valid, but V2 to V1 is not adjacent. Therefore, V2 to V1 is 0. Usually, we can write 1 in simple graph because in simple graph we didn't consider any direction. In digraph, we consider the direction. Okay. Therefore, V2 to V1 here 0. Next, V2 to V2. No, here there is no any self loop. Therefore, 0. Next, V2 to V3. V2 to V3. V2 to V3. Here one arc is exist. V2 to V4. V2 to V3 there is no adjacent. Therefore, 0. Next, V2 to V4. One arc is exist. Therefore, V2 to V4 we can write 1. Next, V2 to V5. V2 to V5. See, V2 to V5, one arc is exist with the direction. Therefore, we can write 1. Next, second row. Second row, third row, V3 to V1. V3 to V1. V3 to V1. V3 and V1 are non-adjacent vertices. Therefore, we can write 0. Like that, we can make the adjacency matrix using this digraph. Okay, I think, is it clear? Okay, next. What's the next matrix? Incidence matrix. Incidence matrix depend on the edge and vertices. The order of the incidence matrix, number of vertices by number of edges. But adjacency matrix only depend on the number of vertices. This is the incident matrix. Incident matrix, here we take one diagram. This is a directed graph. We can make the matrix using how many number of vertices is there here? 6 vertices is there, and now number of arcs, 8 arcs. Okay, we can write 1 when if EI and the edge EJ is here, note here, Xij is equal to 1 if jth edge EJ is incident out ith vertex Vi. See, first example, first you write the vertices and edges. Okay, V1 to E1. See, here V1, this is E1. Okay, so here, notice here, incident out ith vertex. V1 and E1 is incident vertex, but this outside, it should be incident with the outside. Therefore, V1 and E1 are incident vertex with the outside direction. Okay, therefore we can write 1. Next, second one, V1 to E2. Here V1 is there, E2. This is simple. V1 and E2 are not incident vertex. Therefore, we can write 0 like that. Similarly, we can notice V1 to E6. See, V1 to E6. The V1 and E6 are incident with outside direction. Therefore, we can write 1. But E6 to V1. See here. E6. Where is E6? E6. V5. See here. This is V5. V5 and E6 are incident. In simple graph, we consider this is incident. But in digraph, this is not incident vertices because V5 is not incident with the outside direction. This is inside direction. Therefore, we cannot write here 1. See, V5 and E6. Where is E6? E6. So, in this case, we can write -1. Outside means +1 and inside means we can write -1. In this case, we can't write 1, but we should write in -1. Okay, so outside means 1 and inside means -1. Next, one more example. V2, E2. V2 and E2 is the incident with direction outside. Therefore, we can write 1. V2, E2. So, here value is 1. Next is V2 E1, see, V2 E1, this is as incident with inside direction. V2 and E1 are incident with inside direction. Therefore, we can write here -1. V2 and E1. V2 and E1, we can write -1. This is called incident matrix. Okay. I hope everyone clear in this concept. Okay, we will meet in next video. Thank you.